Okay, here we go. We've got a question here about a block of mass m released from rest and it's sliding down a ramp. We have a frictional force, so we're not going to ignore that. Let's have a look at what the kinetic energy of the block at the bottom of the ramp is. Feel free to have a go, and when you're ready to see the answer, press play. Okay, we're going to do a bit of energy conservation here. Now, usually, in the case of zero friction, okay, which is what people always like, we would be very sort of happy to say that we've got potential energy becoming kinetic energy here. Now, this case becomes a little bit harder because we have friction. So what I'm going to say here is conservation of energy. We're going to say that the potential energy at the top here is going to become kinetic energy. However, we're going to lose some of that potential energy also to work done against friction. Our job then is to try and correct the answers so that we can incorporate our work done into against friction. Now, let's firstly rearrange. Okay, we're going to say that kinetic energy is just the difference between our gravitational potential and work. And our gravitational potential is going to be mgh. Now, that's not any of the forms that are on here. We'll come back to that later. And that's going to be minus F times S. Now, F is the friction force, and S is going to be the distance in the direction of the friction force. Now, hopefully you can see that we've got a triangle here, and so that we've got an H is equal to D sine theta. Okay, which is why immediately we're going to start thinking about answers C and D. We're going to rule out A and B because there's no sign there. Okay, and we also can see that the friction itself acts in the same direction as D. We're left then with kinetic energy is equal to mgd sine theta minus F times D, because F and D are in the same direction, or they're parallel to each other. Okay, which is why the answer here is D.